Okay, so now we're on question 4, and question 4.1 says, sketched below is the graph of h of x, which is equal to 1 over x plus p plus q. The asymptotes of h intersect at 1 and 2. Okay, so they tell us those asymptotes intersect. So they're telling us clearly the vertical and the horizontal asymptote. We have to write the values of p and q. So as you can see, they're doing that thing again. This is not the original equation of a hyperbola. This is not what it's supposed to look like, this part. It's supposed to say x minus p. So you have to remember what the original one is. If not, you could end up getting confused. So in order to find that value, I just have to remember that the original equation is supposed to look like this. It's y is equal to a over x minus p plus q. So as you can see, there's no problem with the q, but the p, you just have to be careful there. So p, naturally in the original equation, that stands for your vertical asymptote. So as we can see, the vertical asymptote, it passes 1 on the x-axis. So p is equal to 1, right? And q is equal to 2. We have no problem with the q. So when we substitute that into our original equation, that is y is equal to a over x minus our p value is 1, and then the q value is plus 2. Now, you have to answer them in terms of their p. It doesn't change the formula. The formula is still the same. The a is 1, by the way. Okay, the formula is still the same, but then their p value is just different. So if you see that here, they clearly put the x plus p, okay, but you know the original one is x minus p, you're just going to have to take whatever your p value is and multiply it by -1. Okay, that will give them their p value. So it means that their p value is actually equal to -1. Okay, because you know that this is the original equation, and only if you made p equal to -1 will you get this equation. So if we substituted this their p value into here, it would be h of x is equal to 1 over x, and then you see you have plus p. But now we know p is -1, so that's plus -1. Which really just becomes a -1, and then plus 2. There, it matches up with our equation, which we used the original one for. So just remember that if you see a plus there, it means whatever your value of p is, just multiply that by a -1. So their p, was saying that is equal to -1, and the q still stays 2. So p equals -1, and q is equal to 2, just so that it can match up and we can still end up getting the proper equation. Okay, moving on to the next question. Okay, next question. We have to calculate the coordinates of the x-intercept of h. So what are the coordinates of the x-intercept? Well, let's write the equation of h down first so that we can see what we have. H of x is equal to 1 over x, and of course, you see plus p, but we know their p value is -1, so that's minus p plus 2. So this is our equation, and we just need to find the x-intercept. To find the x-intercept, you're just going to make y equal to 0. So our y value, that's h of x, we're making that equal to 0, and we have 1 over x minus 1 and then plus 2. To solve for x, we can just take the 2 over, so that becomes a -2 is equal to 1 over x minus 1. Okay, and now just to solve for x again, you can put this over 1 and cross multiply. So we're saying the 1 times the 1, which really just stays 1. And then you're saying the 2 multiplied by x minus 1. You're multiplying something that's one term with 2 terms. Remember, this -2 needs to multiply to the x and the -1. So that's -2 times x, which is -2x, and -2 times -1, which is +2. And so this is going to be equal to, I want to solve for x, so I'm going to take this -2x over so that it can become positive, and then I'll just take this 1 over. So we have +2x now is equal to, and we still have a 2 here, so 2, and we took this 1 over, we're taking it over, so it becomes a -1. So 2x is equal to 2 minus 1, which is 1. Then if you divide both sides by 2 to solve for x is equal to a half. So remember to answer their question. The question is for you to calculate the coordinates of the x-intercept. So we need to put it in as a coordinate. So therefore, it means the x-intercept when y is equal to 0, the x value is 1 over 2. So we have 1 over 2 and 0 as our coordinates. Okay, so there we go. That was for 2 marks. And then we move on to the next question. Then we have 4.1.3, which says, write down the coordinate, the x-coordinate of the x-intercept of g if g of x is equal to h of x plus 3. Okay, so there's a new graph called g, and this graph is being translated, and we have to write its x-intercept. Okay, so this is only worth 2 marks. So for you to just go ahead and start applying this translation into the graph, that's going to take long, because then you're going to have to still find the new formula of g and then find its x-intercept. We're going to have to look at how this graph is moving, and you have to always think about this because this is not always the case. First of all, how is this graph moving? Look at the translation going on. We're saying h of x plus 3. Okay, this 3 that is being added to the x, it's only affecting the x. When you are moving a graph and you're only affecting the x, this means that this is either a left or a right movement. Okay, those are the things that affect x. Because if I had a Cartesian plane and I had a point and I called this 1 and 2, and I said, okay, let's move 2 units to the right. If we just move this point 2 units to the right, like 1, 2, our new point is going to be 3 and 2. As you can see, only the x was affected. So when you see only x is being affected, this is either a left or a right movement. Now, because it's saying plus 3, this, I know normally most people will be thinking, oh, because it says plus, it must be a right. It doesn't work like that with graphs when it has to do with the actual equation of the graph, okay? When it says plus, it's actually moving to the left. When it says minus, it's moving to the right. So because we have plus 3, it means this graph is moving 3 units to the left. Okay, so that's all we know about this graph. It's moving 3 units to the left. Okay, so think about however this graph looks, which we already have. We have this graph already. It's only moving 3 units to the left. So if you think about that, the way this graph is just moving 3 units to the left, all that happens is if it moves 3 units to the left, right? This was the old x-intercept. That's where it intersected the x-axis. The new x-intercept, okay, is just going to be this point that moves 3 units to the left. Okay, so we're just going to have to find out now what it's going to be. It's just still moving on the same line. What is this going to be now? We knew this one was a half, right? And now it's just moving 3 units to the left. Now, we're not working with the actual equation of the graph. We're moving them as coordinates, okay? We're starting here and we're moving 3 units to the left. When you move to the left, you're going to subtract. This is when you're working with coordinates. We're actually taking a coordinate on the Cartesian plane and moving it. So from a half, you're going to move 3 units to the left, meaning you need to minus 3 because we're moving to the left on the Cartesian plane. And so whatever a half minus 3 is, that's going to be your x value, okay, of your new x-intercept. So in order to find that, we can just say x is actually just equal to, we're starting at a half and we're moving 3 units to the left on the Cartesian plane. That's why I'm saying minus 3, okay? So when it has to do with notation, it's plus 3 so that you can apply it to the graph. But when you're deliberately moving on the Cartesian plane, you have to actually move according to the direction. Left will be minus, right will be plus. Okay, so x is equal to whatever this is going to be. So you can put this onto the calculator and see what you get. Okay, and a half minus 3, I get negative 5 over 2. So it means that x is equal to negative 5 over 2. Okay, now you see they do ask you to only write down the x coordinate, okay, of the x-intercept of g. So this is fine. You don't have to write it as a coordinate. Okay, moving on to the next question. 4.1.4 says the equation of the axis of symmetry of h is y is equal to x plus t. We have to determine the value of t. So they just want that last point. Okay, they gave us the equation of that axis of symmetry. Please notice y is equal to x plus t. They're telling us the gradient of this. it is in the form of y is equal to mx plus c. So it means that our gradient m is actually equal to 1. So clearly they're asking us for the equation of the axis of symmetry of h, that hyperbola, with a positive gradient. Okay, so you have to think about the equation of the axis of symmetry, how they work. When you have a hyperbola, you have axis of symmetry on these hyperbolas. So something like that and like that, right? So the axis of symmetry is the line that really just divides the graphs into two equal parts. They make the graphs look symmetrical on the one side and the other side. So there are two. There's one with a positive gradient. The one with a positive gradient has an increasing function, straight line. So the straight line is increasing. You read functions from the left moving to the right. As you can see, if you read it like that, you can see that this graph is increasing. So this is the straight line, right? That axis of symmetry of the hyperbola with a positive gradient. And its equation is very simple. If you remember the general equation of hyperbola, you will remember this one. The general equation of hyperbola is y is equal to a over x minus p plus q. All you have to just say is, oh, x minus p plus q. That's all. So the equation of that straight line, that axis of symmetry with a positive gradient, is y is equal to x minus p plus q. That's all. Okay, so I'm not really going to deal with the negative one because the question is not asking for that here. So we just need to find the value of p and the value of q. Now, not their value of p and their value of q, okay? Now, this does not refer to their value of p, okay? It refers to the original value of p. So, in this case, we're saying we know that p was equal to 1, okay? Positive 1. When we look at it as a graph, okay, this is your vertical asymptote. So originally, not here, they altered that a bit. P is equal to 1, as we can see here, and Q is equal to 2. So we're going to use those values, the original one of it. Okay, so we're just saying that finally it just means that y is equal to, let me just put that in black, y is equal to x minus our p is 1 and our q is positive 2. So we have y is equal to x. Negative 1 plus 2 is positive 1. And so remember, the question was for you to determine the value of t. So it means that if it is in this format, we can now see that t is actually equal to 1. So just conclude, therefore, t is equal to 1. And that's our final answer. Okay, so I'm adding this to the explanation on 4.1.4 because when I was looking at this question while editing, I noticed that it's actually an easier way to solve this. Remember, it's only worth 2 marks. Notice that in the beginning, they already give you the equation of this line. They just don't give you the value of t, and you have to find that. Since they gave you the equation of the line, this really helps us a lot because, so this is just an alternative way of solving this. So we could have said y is equal to x plus t, and then since this is an equation and only one thing is missing, if we had an x and an y value to substitute into this equation, we would be able to find the value of t. Now the thing is, we actually do have an x and a y value to substitute. Do you remember that in the beginning, they mentioned that we had the asymptotes of h intersect at this? You see, where you have your asymptotes, and let me just remove this because this is for the explanation of the next question. Okay, when we have the asymptotes, this is what we have. You see that the vertical asymptote is 1, the horizontal is 2, and do you see that they intersect at this point? The point they intersect at is going to be that x value 1 and the y value of 2. That's why they mentioned that. So that line of symmetry, okay, the line of symmetry, whether you're taking the one with the positive gradient or the negative, but of course it's going to be the one with the positive gradient in this case because they told you that your gradient was clearly 1 in the equation. Okay, so if we're looking at this one with a positive gradient, then we have a point of intersection. We have a point on this line. So to find t, you're just going to have to substitute this point of intersection 1 and 2. So we could have just done that instead. So this is what we're going to do instead. we have 1 and 2, which we're going to substitute into this equation as your x and your y value. So that would be 2 is equal to x is 1 plus t, and then you just take 1 over, and you'd get that 2 minus 1 is equal to t, and so therefore t would be equal to 1. So there is an alternative way of substituting, and here you're definitely going to get your mark, first of all, for your substituting of those 2 points and for your answer of t. In a way, when I look at it like that, it kind of also seems as if you're getting a mark for substituting the value of p and q and then your answer of t. I think it can be used like that. Okay, but this is an alternative way of doing that, and that's how you can get t. Okay, moving on to the next question. Then 4.1.5 says determine the values of x for which negative 2 is less than or equal to 1 over x minus 1. Don't get afraid when you see these types of questions. You need to just actually put this in its correct order. What they did is they took the graph of h, and you see the graph of h was, we know h of x was equal to 1 over x minus 1 plus 2. And all they did was took the 2 and put it over. So just bring the 2 back and then it'll make more sense. So this equation is actually, if we take this negative 2 over on this hand side, on the left, we're going to have 0 is equal to, not equal to, less than or equal to 1 over x minus 1. And then this is going over, so we have plus 2. Now this makes more sense. So they're just saying we need to find, and let me just rewrite it in a way that this comes first, so it just looks simpler. So I'm saying 1 over x minus 1 plus 2, but you still have to follow what the sign says. So I'm going to put the 0 here, and you need to show what exactly, okay, this is saying. Notice that the inequality, the mouth, right, this open side is facing this. So it is to face this expression. So we're going to draw it facing the expression, and we have an equal to. So this is really what they're saying. You need to solve or find the values of x for which this, okay, the graph of h is going to be greater than or equal to 0. That's what we're just trying to find out. Where is this going to be greater than or equal to 0? Okay, so remember, h of x refers to the y values of the graph. So we're just looking for where are the y values either greater than or equal to 0. Okay, so if we look at the graph, where are the y values of this graph greater than or equal to 0? So where are they greater than or equal to 0? Looking at the y-axis, because they're y values. The y values that are either greater or equal to 0, they start here. They start at 0, and then there's everything above here. These are all y values that are greater than 0, and this is a y value equal to 0. You're going to highlight the parts of the graph that have y values greater than or equal to 0. So that would be here. If we look at this graph, see, it has a y value equal to 0. And then here, it has y values greater than 0. And here as well. And all the way here, everything here on the graph has y values that are either equal to 0 or greater than 0. All of these y values are positive. But then it doesn't only happen on this part of the graph. You see here after the asymptotes, we also have here this point over here. It has a y value greater than 0, and this point greater than 0 as well. So everything here, okay, and above also has y values that are greater than 0. Okay, so we're only going to take everything that has been highlighted now in red. We have to answer them in terms of x. Okay, so let's see how we can answer them. First of all, the y values that were greater, okay, or equal to 0. The y value that was equal to 0, the x value that belongs to that, as you can see here, that is an x-intercept. And we knew what that was. That was a half. Okay, so we know here it starts at a half, okay, where x is equal to a half. And then these parts of the graph we also have to take. So what are the x values that belong to these parts of the graph? Well, let's highlight it down to the x-axis and see where this belongs. So as you can see, look at these x values. These are values that are what? Than a half. You have to compare it to a half. There's nothing else to compare to, because at a half, we have y values that are equal to 0 or y value that is equal to 0. So this is where x is either equal to a half or less than a half. Because you see it's moving towards the left-hand side. These x values are values that are smaller than a half. So that's one part of the solution where x is either less than or equal to a half. Okay, so that's one side that we have. Then we have to look at this other side because this was also highlighted. Okay, so let's find out what are the x values that belong to this highlighted part of this graph. Well, notice that after the 1, right, then you're going to have the x value that belongs to this highlighted part of the graph is going to be somewhere up there. And of course, that has a y value greater than 0. So we're going to take these. If you highlight them, you see where these are coming from now. They are heading towards the right-hand side, but they start after 1. They cannot start at 1. It's not possible because there's an asymptote here. We don't have any solution here. That's why there's an asymptote. So these are values that are greater than 1. So x is either less than or equal to a half, or x is greater than 1, not equal to 1. So this is our solution for this. There's no other, we can't really see any other place that this happens except for those two places. So we say that x is less than or equal to a half, x is less than or equal to a half, or x is greater than 1. And that's going to be our answer for that question. Okay, and now we move on to the next question. Okay, so on the next question, we have 4.2. They say the graphs of f of x is equal to x squared minus 4x minus 5, and g of x is equal to a times 2 to the power of x plus q are sketched below. So we have a parabola and we have an exponential function. Okay, and now they say that e at h are the x-intercepts of f. Okay, so we have e and h, x-intercepts. They tell us that c is the y-intercept of f. Okay, and it lies on the asymptote of g. So that's going to give us a lot of information about that asymptote, seeing that this is a y-intercept, so it has a y value. And then they say the two graphs intersect at d, the turning point of f. Okay, also going to give us a lot of information about this graph of g. So the first question is to write down the y coordinate of c. So just the y value of c. Well, c, like they said, is the y-intercept of f. Okay, and they gave you the equation, the formula of that graph. Remember, it's in the form of ax squared plus bx plus c. So they're telling us already what the y-intercept is. This c, the small letter c at the end, always stands for your y-intercept. So we know now the y-intercept is -5. So obviously as a coordinate, that will be 0 and -5. But they're only really asking you for the y coordinate of c. So to find the y coordinate of c, we'll just say y is equal to, and what is that y value? We found out that it is -5. So -5. Then 4.2.2 says determine the coordinates of d. So to find the coordinates of d, remember this is the turning point, like they told us, the turning point of f. So we already have c, let's just put that down, that is -5 over there. And now to find d. Well, they gave us the equation of f of x and it's in standard form. So to find the turning point when your equation is in standard form, you find it like this. Let me just rewrite what we have. Okay, so this is f of x, and to find that turning point, you're going to have to use this formula. X is equal to -b over 2a. There is a longer method where you have to complete the square, but that takes too long. You can just use this formula instead. So when we have this now, we can go ahead and say x is equal to negative, and our b value, as you can see, is -4. A is 1, okay, and that's really all we need, b and a. So bracket -4, open, and then over 2, then times 1. Then let's go ahead and find this. So that's just going to give you +4. +4 divided by 2 is 2. So x is equal to 2. So this is the x value belonging to the turning point. So if the x value is 2, to find the y value, just substitute this 2 into the equation of this graph and to give you the y value. So we're just going to take 2 and substitute it into f of x. So we're saying f of 2 is equal to 2 all squared minus 4 times 2 minus 5. And you can substitute this into the calculator. And we get negative 9. So f of 2 is equal to negative 9. And so the coordinates of D is really D is just 2 and negative 9. Okay, so that is 4.2.2. Moving on to the next question. Okay, 4.2.3 says determine the values of A and Q. So A and Q, that was from the, yes, okay, so this was from the exponential graph. So A and Q. Well, to find Q, whenever you're trying to find a hyperbola or an exponential function, you have to start with your asymptotes. If you find your asymptotes, and then you'll be able to find the other variables that may be missing by just using like a point, okay? So as long as you have an x and a y value. So to find Q, well, they told us something very important about that. They specifically said that C, right, that y-intercept that lies on F, that it also lies on the asymptote of G. That is a very important piece of information. Because this point 0 and negative 5 lies on G, its y value is negative 5. That means that this asymptote is passing negative 5 on the y-axis. So because it's a horizontal asymptote, it is passing negative 5. It means that that horizontal asymptote, the equation of it is y is equal to negative 5. So we know that now, and so that means we know the value of Q. That Q is actually equal to negative 5. So we can put that down first. Q is equal to negative 5. Okay. Then now that we have Q, it means only one thing is missing. In equations, when you only have one variable missing, you usually only need one piece of information to find that missing variable. So it means that in this equation, we just need at least 1 point in order to find that. So looking at the graph of G, what other points do we have on G? We have D, okay, the point of intersection of F and G. They said that they intersect here, so it means they have the same point. So because we already found the coordinates of D, which was negative 2 and negative 9, negative 2 and 2 and 9, sorry, negative 9. So 2 and negative 9, we can substitute this into this equation and we would find A. Okay, so let me just rewrite that equation down. Okay, so this is the equation, but we know now that the Q value is negative 5. And now we just have to substitute that point D, which of course we knew was 2 and negative 9. So if we substitute this, we'll find the value of A. This is your X value, this is your Y value. So I'm saying the Y value is negative 9 is equal to, we have A multiplied by 2 raised to the power of 2. So we've substituted X and Y into the equation now. Then we have, of course, minus 5. Now, in order to solve for this, as you can see on this side, on the right hand side, we have two terms. This is the first term and this is the second term. Remember, terms are separated by plus and minus signs. So we need to get rid of, since the A is already multiplying to this, we have to get rid of the negative 5. And you can do that by taking it over. Okay, since it's minus 5, you take it over, it becomes a plus 5. So that is 5 minus 9, okay, is equal to A multiplied by 2 squared. 2 squared is 4, so that's A times 4. 5 minus 9, that gives you negative 4, is equal to A times 4. And then we just need to solve for A. So get rid of the 4 by dividing both sides of the equation by 4. And so that means that A is actually equal to negative 4 over 4, which is negative 1. So there we got A as well. Okay, so remember they did say find the values of A and Q. So this is Q and this is A. And there we go. So we move on now to the next question, 4.2.4. Then question 4.2.4, write down the range of G. So they're asking a lot of questions that you should know about specific types of graphs. So the graph of G is an exponential graph. We know the equation of the graph. We also know the asymptote. The range of it depends on how it looks, okay? So because this graph is below the asymptote, it's only going to have, remember the range refers to all the possible y values of the graph. Because it lies below its asymptote, it's only going to have y values that lie below this. It's going to have a y value here, and here, and here, it's only going to have y values that lie below the asymptote. It won't have any y values above here because the graph is not even here. Okay, no, there's no g here, but it's all down here. So to find the range of this graph, you're saying that the range of all the possible values of y is where y is going to be, and look at the direction it's heading down, okay? It's going to be less than -5. Now, you don't say less than or equal to. This is not a parabola. At this point, okay, at -5, that y value, we have an asymptote, so it means the graph will never touch this. So it doesn't have a y value of -5, but it does have y values that are all less than -5. So that will be your range. So y is less than -5. Okay, moving on to the next question. Okay, so the last question in question 4 says, determine the values of k for which the value of f of x minus k will always be positive. So we're taking this graph f of x minus k, right? And we need to find the values of k for which this will always be positive, for which it will always be. So positive just means the y value needs to be greater than 0. Okay, so we have to actually look at the graph to be able to move this. So we're looking at the parabola f, right? And we have to move this graph in such a way that it's always going to be positive. So right now, you see, the thing is that it has negative y values. Okay, this point over here, its y value is negative. That point over there, its y value is negative. We don't want that to happen. We want everything to be positive. You have to catch it from where the y values start. This graph's y values, because it's a parabola, it starts here at the turning point. This is the last place, okay, it's going to have this y value. So if we can actually move this graph in a way that its y value will not be negative anymore, then it's always going to be positive. So think about how to move it. If you moved it down, that would not solve the problem, because now your graph is sitting here and it still has negative y values. It has even more negative y values. So you have to move the graph up instead. So we're going to move the graph up. So if we move the graph up, let me just draw a parabola and pull it up. Okay, so this is our parabola. If it was here before, we have to move it up. But how far up? You see, if you just move it till here, that doesn't really help. It still has a negative y value. So if you move it all the way to the x-axis, and it's sitting on the x-axis, then we can see that if you just move it any further than this, then it's going to always have y values that are positive. So we just want it to have y values that are positive, not necessarily 0, just positive. So it needs to go beyond this point. So how far up did we move it? Well, we moved it up by going from this point to this point. And if you're looking at the y values, that is from -9 all the way to 0. So we moved it 9 units up. It needs to just move by 9 units up. But now we need to know how to actually say that to them, given what they told us. They told us that the graph that we have is f of x minus k. And we need to determine the values of k for which it's going to always be positive. So f of x minus k, this is what we have, f of x minus k. So think about what k needs to be for this graph to shift up. If you just said f of x minus 9, this would not work if you made k equal to 9, because f of x minus 9 means you are taking the graph and actually moving it down. So be careful, because they put a minus there. We need to make this f of x minus and then minus 9. That way, if we multiply the negative times that negative, we have f of x plus 9. And now that we have this graph will move up. So we have to be able to monitor this and see what should k be for this graph to constantly have positive y values. Okay, so we already know it has to do with k and -9. We just need to know, should it be greater than, should it be less than? Okay, if you made k to be greater, and that's where you have to think about the type of numbers that you have. If you made k to be greater than -9, you have to think about the types of numbers that are greater than -9. On a number line, right? -9, let's say -9 was here. Numbers greater than negative 9 will be moving towards the right. These are numbers like negative 8 and negative 7, you see. So looking at this graph, it has to move more than 9 units for it to even touch the x-intercept, okay, the x-axis. Okay, so thinking about these numbers, if you had to make x greater than negative 9, then you're going to say that, k greater than negative 9. Then you're basically saying that k can be numbers like negative 8. Well, let's see if this actually solves the problem if we make k equal to negative 8, okay? If you said f of x, and then you said minus negative 8, right? Then we have f of x, and then if you multiply, that becomes plus 8. Well, f of x plus 8, it needs to be able to move this graph in a way that it's always going to be positive. If you move it, this means we're moving the graph 8 units up. If you move this graph 8 units up, that does not solve the problem because it's only moving 8 units up. And so it's going to land here, meaning your graph still has negative y values. That's the thing. You have to think about the type of numbers that you have. So clearly, if you make k greater than negative 9, it's not going to work. Let's think about the other direction then. How about we make it to be less than negative 9? So think of numbers that are less than negative 9. That will be things like negative 10, negative 11, and so on. So let's say k was equal to negative 10, right? It's just substitute in place of k negative 10. So now we're making it less than, okay? So f of x needs to be, and then we have minus, and the k is negative 10. So if you multiply this in, you have f of x plus 10, which is great because now it means that this graph is going to move 10 units up. See, when it reaches 9 units, it moves an extra unit, and now the graph is here. There. Everything that moves beyond 9 units is always going to be positive. This graph will always have positive y values. So that's why you have to think about it as in the relationship between numbers. So this means that k must not be greater than negative 9 because you see numbers greater than negative 9 are negative 8 and negative 7, and that's not enough to move the graph. You need to get the graph to a point that it actually moves beyond this so that it can have positive y values. So k just needs to be less than negative 9. You need to think about that carefully, okay, with your graph. So k is less than negative 9. That is our answer for this question. And that is it. So that is the end of question 4. And then we'll move on to question 5. Okay, so question 5, we have been given this. So the graphs of g of x is equal to 2x plus 6, and we have the inverse of g are shown in the diagram below. D and B are the x and y intercepts respectively of g. So there we go, we have D and B. And then they tell us that C is the x-intercept of the inverse. Okay, the graphs of g and the inverse intersect at A. Okay, so you see, your knowledge on inverse is going to help you a lot on inverse functions. So the first question we have, write down the y coordinate of B. Okay, so the y coordinate of B. Let me just get rid of these ones because I just want to work on each question one by one. Okay, so they want the y coordinate of B. So I'm already saying y is equal to, so let's see what B is. As you can see, B is on the y-axis. Okay, and it's on this graph of G. So it is the y-intercept of B. And they already told us that as well. So since it's the y-intercept, then remember, do we have the equation of G? We do. We have the equation of G. This is the equation of G. And it's in the form of y is equal to mx plus c. So if that is our gradient, and this is our c, c is always your y-intercept. So it means that the y-intercept is 6. So that y value of B is 6. Okay, so y is equal to 6. So as a coordinate, it's of course going to be 0 and 6 because the x value is 0. Okay, so that's the first question. Moving on to the next question. The next question says determine the equation of g of, okay, g negative 1, which is the inverse, in the form of, so in this form. So we need to make sure that that notation is also correct. So we're just finding the inverse. Okay, so to find the inverse equation, you're just going to take the original one and we're going to write it as y is equal to 2x plus 6 first of all. Now that we have it in this format, you're going to swap the x and the y value. So in place of y, we're going to put x, and in place of x, we're going to put y. So 2y plus 6. Then you're going to try and make y the subject. So to make y the subject here, we first have to get rid of this positive 6. So we can take that over. And so that is going to become x minus 6 is equal to 2y. Now to solve for the y, to make that the subject, you have to get rid of the 2 by dividing both hand sides by 2. So this is really saying that y is equal to, so this is what we have here. Now remember, in front of the x, there's actually a number. There's an invisible 1 in front of the x. So if you look at this, this is saying 1x divided by 2. You can say the 1 divided by 2, which is just 1 over 2, and then put the x there. And then we have negative 6 divided by 2, which is negative 3. Okay, so this is the equation, but remember you need to write it in that format. So I will just leave it as this is g negative 1 of x. The inverse is equal to a half x minus 3. And that is our equation. Okay, moving on to the next question. Okay, 5.3 says we have to determine the coordinates of A. So look at A. A is the point of intersection between these two graphs. So it's great that we have the equation of G, and we also have the inverses equation. If you want to find the point of intersection, this is the point where their x and their y values are exactly the same. So to find the point of intersection, you would make this equation equal to this equation. So we're going to take the equation of g of x, and we're going to make it equal to the inverse of g. Okay, so that is going to be, like we already know, this one is 2x plus 6. That's the equation of g of x. 2x plus 6 is equal to a half x minus 3. Okay, so just have to solve for x now. So I'm going to put the x's on one side. So we have 2x, and I'm taking that x over, which becomes a negative, a half x, is equal to, and we have negative 3 still on this side, and we're taking the 6 over, and that becomes a negative 6. So 2 minus a half is going to give you 3 over 2, okay, because that is 1.5. 2, just take away a half. Okay, so 3 over 2x is equal to, and then we have negative 9. Now we just have to solve for x. So we're going to divide both hand sides by 3 over 2. So divide by 3 over 2 and divide by 3 over 2. Okay, so we can go ahead and divide. Okay, so negative 9 divided by 3 over 2 is negative 6. So it just means that x is equal to negative 6. That's the x value of this point of A. We found its x value. Now, in order to find its y value, just remember that it lies on both lines. It lies on G and on the inverse. So you can substitute that x value into either one of these equations. It's still going to give you that y value, since this is the x value over here. Okay, so I'm just going to choose the easier one, the one that seems easier. I'll go with the 2x plus 6. So I'm substituting into g of x. So g of negative 6 is equal to 2 times negative 6 plus 6. And let's just see what we get here. So that's going to give you negative 12. Negative 12 plus 6 is negative 6. So our coordinate is, for A, is just negative 6 and negative 6. Okay, so that is question number 5.3, and that is for 3 marks. Moving on to the next question. Okay, the second last question is calculate the length of AB. So the length of AB, to find that, we just need the coordinates of A, which we know is negative 6 and negative 6, and the coordinates of B. Now, with B, we already found that before. We know that B, the y value is 6, because it was the y-intercept of G. So it means its coordinate is going to be 0 and 6. So that's really all there. So B is 0 and 6. Then you're going to have to remember the formula for the length of a line. So the length of a line, we find that by saying AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, even if you started with the y2 minus y1 or the x2 minus x1, it doesn't matter. It will still be the same thing. So AB is equal to, okay, so you also can label these. This will be x1, this will be y1. Those are your two first points. Then this is x2 and y2. So this is the square root of 0 minus -6. So minus -6 will end up just becoming a +6. So that's just +6 all squared. Then plus we have y2, which is 6 minus -6 as well. So that just becomes +6 all squared. And so AB is equal to, and we can just substitute this into the calculator and see what we get. Okay, so this is what we get. Okay, then you can round off to 2 decimal places. So that is going to be 13.42. So round it off to 2 decimal places because 6 is higher than 5. So it rounds up basically and adds a 1 to that one. So we have 13.42, and that is the amount of units that AB would be. Okay, and now we move on to the last question in question 5. Okay, so the last question, 5.5, says we have to calculate the area of triangle ABC. Okay, so triangle ABC. So let me just draw the triangle out so that we can look at it and see how we can find the area of this. Okay, so this is the triangle that we have. And looking at this, there's a number of ways that you can find the area of this triangle. So I'm going to just try 2 methods here, but then there would be, of course, other methods that you can use. First method, we're trying to find the area of this triangle. We can use the area rule. And the reason I'm saying the area rule is because we already have the length of AB. So the area of AB, that was, we already said this is 6 square root 5. Okay, so I'm going to use it as this, just so that the answer can be perfect. Even if you used it as this, I don't see a problem because AB was one of the things they actually asked for. Okay, but to be safe, I'll just take 6 square root 5. So if we're using 6 root 5 as AB, now there's something about AC. We can actually find this. Okay, the thing about AC, the length of it, well, we can find the coordinate of C if we want to, because remember, G is the original function and this is the inverse. So the X and Y values just swap. So think about it like this. This coordinate of 0 and 6, right, on the original graph. On the inverse, this coordinate is going to be 6 and 0. Okay, so that is an x-intercept. That is going to be what C is. C is the x-intercept. So then that one is going to be 6 and 0 because the X and Y values just swap. Then you could have gone and just found the length of AC. But in a way, you don't have to actually do this. The reason why is because the original function, okay, and the inverse, they are symmetrical about that line y is equal to x. So if we drew that line y is equal to x, then these two are going to be symmetrical about this line. So it means that we have this point A over here. But for example, if we get to B, right, whatever this line is doing from A to B is exactly what this line is going to do from A to C, since that is the inverse of this point over here. Meaning these two lengths, AB and AC, they're going to be exactly the same. Okay, and really this is because if you wanted to go ahead and find the length of this line, you will notice that you have AC, right? It's equal to the square root of, if we are taking the X and the Y values, I'll start here. So that is still 6 minus -6, which is of course 6 plus 6 all squared, plus 0 minus -6, which is 0 plus 6 all squared. That looks familiar again. We still have a 6 plus 6 all squared and a 0 plus 6 all squared, which is the exact same thing we did. Very similar, just, you know, this one is now first. It's the same thing we did to find AB. So that's why I'm saying they're really the same length. You don't actually have to find AC. We know that they're the same length. So this is also 6 square root 5. So notice I just found the two sides, okay? This side AB and this side AC. What we can do now is we can find this angle in between. So if we find this angle over here, we'll be able to find the area of this triangle using the area rule. Okay, so all I'm going to say so long is I know the coordinates of C, that's 6 and 0, and I know that AB is equal to AC. That's all I'm going to put down so long. Okay, so this is all I put down for now. So AC is equal to AB, which is 6 square root 5. Okay, now that we have that down, we just have to find that angle, this big angle over here. Now to do that, we have to use angle of inclination. So to find the angle of inclination, okay, let's just see how this angle is formed. It doesn't mean that this is just formed by finding the angle of inclination of something. First of all, we have to do this. Draw a imaginary x-axis. Draw an imaginary x-axis. So if we do that, let's see how this angle in yellow is formed. We can find that angle by finding, first of all, the angle of inclination of the line AB. So if we find the angle of inclination of AB, that entire line, right? And then we find the angle of inclination of the line AC, this angle. And then if we take this big angle and we subtract it by this little angle, we will be left with this angle. So that's how we can find this angle in yellow, that angle BAC. So let's go ahead and find the angle of inclination of these lines. So we're going to start with the red one, the angle of inclination of AB first. So we'll find that by saying tan of theta, I'm going to call that theta of AB, so I remember that it belongs to AB, is equal to the gradient. So now what is the gradient of AB? Well, we have the equation of the lines, so we know what the gradient of AB is. AB is on this line of G, and this was its equation, meaning its gradient, M, is 2. So we know that. Now we know that M is equal to 2, so I'm just saying tan of theta is equal to 2. Then we can solve for theta of AB. So I'm saying theta of AB is equal to, and we're taking tan over, and it becomes the inverse of tan, shift tan of 2. So on your calculator, you're just going to press shift and then tan, the second function of tan, and of 2, and we get 63.43. Okay, so I don't want to round off yet. I want to round off at the end. So I'm just going to leave this as AB, theta of AB is equal to 63.43 and then 4, okay? I'm not rounding off yet, so we'll probably just use it as this. Then after finding that, we have to find the next angle of inclination. So we just found the one for the red line. Now we have to find the angle of inclination, okay, for this blue angle over here, which is the angle of inclination of the line AC. So let's find that angle now. So AC, we also have the equation of AC because it's the inverse of G. The equation of that was 1 over 2 and then 1 over 2x and then minus 3. So we know the gradient, it's 1 over 2. So we could just put that down. So finding theta of AC now. So tan of theta of AC is equal to, the gradient is 1 over 2. So theta of AC is equal to second function of tan, and we have 1 over 2. Then theta of AC is equal to, and we can also find that if we want. It's not even necessary to be finding these. What we can do is, I'm just going to still put the answer, but I'm not really going to use it as a decimal. So 1 over 2, which is 26.565. So 26.565, and I'm not rounding off yet. The whole goal here is just to find that angle inside this one. So remember again, we find this angle by taking this larger angle minus this little angle. Okay, so I'm just finding that angle BAC. So I'm going to name it. I'm going to take the bigger angle minus the smaller angle. So BAC, we'll find that angle by saying theta of AB minus theta of AC. Okay, and that's why I don't know why I found it like this. I could have just taken it as shift tan of 2 minus shift tan of a half, just so that nothing is rounded off. Okay, so this is the shift tan of 2, that's the bigger line, okay, the bigger angle, and shift tan of a half, of course, is the smaller one, AC, that one. Okay, so we know now BAC is equal to 36.87 degrees. And now we can use that angle. Okay. But of course, if you want it to be exact, then I would suggest that you just use it like this rather, as it is here. Okay, theta of AB minus theta of AC. So this is what I mean. So remember, we're trying to find the area of that triangle ABC. So A, B, and C. And we're using the area rule. So the area rule says half multiplied by, now see, we're multiplying by this line AB multiplied by AC, and then we're going to say sine of this angle in the middle. Okay, so multiply by AB, multiply by AC, and then sine of angle BAC. So if we do this, this is going to be a half multiplied by AB. We already knew that to be 6 square root 5. And of course, AC is also 6 square root 5. So multiply by 6 square root 5. Then we're saying sine of this angle. So if you want to be exact, instead of using this, that has already been rounded off, you could have said sine of, then put all of that in. So shift tan of 2 minus shift tan of 1 over 2. Okay, so you could also just do that, just to be exact. Or you could use this, but maybe a decimal might be off. It also might not be, but then again, we are multiplying, so that could happen. So I'm just going to go ahead and say a half multiplied by 6 square root 5, again multiplied by 6 square root 5, and then make sure you're coming out of that radical. And then you say sine of, and I'm going to say shift tan of 2 minus shift tan of a half. And then when I come out of that, close the bracket and close finally that bracket for everything. And we get 54. So it means that it is 54 units. I think if we rounded off, it would have definitely affected it. Let's see. So if we rounded off and we use this angle instead of putting all of this in, like how we find the angle, I'm sure it would have just given you a rounded off answer. Okay, so you see, it wasn't going to affect it that badly because you would have still known, oh, okay, this is 54 units. So it wouldn't have been a bad thing. It's still fine. Okay, so that is the way to find that 54 units squared. Okay, and let me just show a second way of doing this that I see that we can also do this. And I'm just going to show this method because this isn't really, this is a video. It's not a one-on-one session where, you know, we're working against time or anything. So we can go ahead and look at this diagram again. See, the second method that you could use is, first of all, instead of finding an angle, we could just use the fact that we know naturally the area of a triangle is equal to, or right angle triangle, a half multiplied by the base multiplied by the height. But we would need a perpendicular height for this. So we can actually construct one. You see, the fact that these two, okay, are the inverse of each other, it means they're symmetrical across this line, y is equal to x. So this can become our perpendicular bisector. This line is going to bisect BC, right, into two equal parts. And so it's going to be perpendicular to BC. So this can be our height. Now we can go ahead and try and find the height of this triangle. And then if we have the height, we also have the base of the triangle. And we can just use that to find the area of it. So in this one, the only thing that you have to work on now is you don't have to find any angles. You just have to focus on trying to find the length of BC and that perpendicular height. Okay, so that's just from here, of course, to that point of intersection. Okay, so to find that height, first of all, you would need the coordinate of C. When you find the coordinate of C, just knowing that it is the inverse of B as 6 and 0, you would be able to find now the midpoint. Since we know this is a perpendicular bisector, okay, it's perpendicular to this. So we would find the midpoint of this, and that would be, of course, the points that we have here, that intersection of our height and BC, that. Okay, so let's go ahead and find BC first, the length of BC. So we know that B is 0 and 6, and C is 6 and 0. And let's see what we get. That's really 6 squared and negative 6 squared. And that is going to give us this. But it's better to leave it as a set. So we're just going to leave it as a set, 6 square root of 2. So BC is equal to 6 square root 2. We have BC now. Now all we have to find is we just need to find this height. To find the height, remember BC, right? The midpoint of BC is going to be this point that we have over here. So let's just find that midpoint. Finding the midpoint of BC now. Okay, so we're going to say midpoint of BC. So we're going to find this by saying x1 plus x2 over 2. So that's x1, 0 plus 6 over 2. And then, of course, y1 plus y2 over 2. So that is 6 plus 0 over 2. That's just going to end up being 6 over 2, which is 3. And that's also 6 over 2, which is also 3. So that's 3 and 3. Okay, so we have that midpoint now. It's just 3 and 3. I'm going to call it M, which is 3 and 3. Okay, now that we have this, we just want to find this perpendicular height, this AM. Okay, so we're going to call it the perpendicular height. So A is -6 and 6, M is 3 and 3. So here we have these, and I'm just going to find AM, or that perpendicular height. So that is going to be equal to the square root of, and we're saying x2 minus x1. So I'm just going to say 3 minus -6, which becomes a plus 6 all squared, plus same thing, 3 plus 6 all squared. And then if we find this is going to, let's just see what it gives us and put it in third form. So we get 9 square root 2, 9 square root 2. And now we have everything to find the area of this triangle. So the area of the triangle, again, is going to be found by saying a half times the base times the height. We have the base of BC, we have the height of this. So we can just find it now. Area of this triangle. So now I'm just going to put that formula down. The area of triangle ABC, we find that by saying a half multiplied by the base multiplied by the height. So the base was BC multiplied by the perpendicular height. Okay, and I'm just going to leave this as the perpendicular height like that. So that is a half multiplied by BC, which we know BC was 6 square root of 2. So that's 6 square root 2 multiplied by the perpendicular height, which is 9 square root of 2. And there, again, we get 54 units. So you see, it still agrees with each other. Whether you use the area rule or use the area of a triangle with a perpendicular height, we still get 54 units. Okay, so that is that question, and that is question 5. And then we move on to question 6.